Today we are going to discuss what's inner product, its properties, then length, distance, and angle between two vectors in inner product space. So inner product is a generalized case of dot product, okay, and it's defined as a function from v cross v to r, and here v cross v is nothing but a pair of vectors from vector space is selected, and it is mapped to a real number, and if that function satisfies these five properties, then we can say that's an inner product. Okay, that's the definition of inner product. The first property is inner product of u comma u, that is same element inner product will be always greater than or equal to 0, and it's equal to 0 when if and only if when u equal to 0, that is for a 0 vector only the inner product u comma u will be 0. Okay, then next property is inner product u plus v comma w can be written as inner product u w plus inner product v w. Okay, that's another property. Then we multiply one vector with a lambda, so we get inner product lambda u comma v can be written as lambda can be taken as outside, so lambda inner product u comma v. Then next property is inner product u comma v can be written as inner product v comma u. So these are the five properties. So we need to verify these five properties for a function to be an inner product. So this is the definition of inner product. Okay, let's take an example problem. Here the inner product is defined as u1 v1 plus 3 u2 v2. So u is given as 1, 2, v is given as 3, 4. So we need to calculate the inner products. That's the question. So inner product u comma v can be written as, what's the equation, u1 v1 plus 3 u2 v2. Okay. So inner product here u is 1 comma 2. Okay, 1 comma 2, and v is 3 comma 4. Okay, 3 comma 4. So how can we write for u1? U1 is what? First vector's first element. So first vector's first element. This is the first vector u. This is the second vector v. So here we need to take first vector's first element as u1, u2. Then second vector's first element as v1, second element as v2. So substitute these values. What we get? For u1 v1 we can take 1 into, for v1 we can take 3 plus 3 into, instead of u2 we can take here 2, instead of v2 we can take here 4. Okay, 4. So the answer will be 3 plus 6 into 4, 24. Okay, so 27. So 27 is the answer. So here we have calculated an inner product. Given inner product is given, u comma v is given, we have substituted u v here such that we get inner product as 27. So this is the answer, and this is how we can uh, calculate the inner product. This is how we have to substitute values. Suppose u is 1 0 and v is 2 3. What is inner product? Here. Okay, comment your answers u comma v. For this u and v, what is the value of inner product u comma v? Okay, comment. Okay, now let's go into we have to define length, distance, and angle for vectors in vector space v. Okay, so for that let's consider two vectors u comma v in vector space inner product space v. Okay, so the length of u equation is nothing but length of u equal to inner product square root of inner product u comma u. So length of u equal to square root of inner product u comma u. So what's the length of v? Length of v is nothing but the square root of inner product v comma v. Okay. So now for the next we have to find next is distance. So here the distance is between vectors u and v in vector space V. So for that, let's consider a vector v here and u here. Okay, u, and connecting this v and u like this using a vector called x. So how can we write? V plus x can be written as u. So x can be written as u minus v. So u minus v is the distance between u and v. Okay. So uh, the length of any vector like length of x can be written as length of u minus v. So that's written here. Okay, length of u minus v. So for calculating distance, the equation is square root of that vector comma that vector. That's here u minus v comma u minus v, since we have to calculate the length of u minus v. So in previous we have to find the length of u. So here in the product u comma u. Okay, I think it's clear. Now in order to find angle between these two vectors, the equation between the angle between u and v can be written as cos theta equal to inner product u comma v divided by length of u into length of v. Okay, this is how we can calculate the angle between two vectors in inner product space. Okay, this is the equation. So in case of dot product, it is here u dot v. So here for inner products we can write inner product u comma v divided by length of u into length of v. Okay, and if the two vectors u comma v are in orthogonal, so they both having 90 degree or orthogonal, then we can say that inner product u comma v will be equal to 0, which is similar to that dot product, that is v dot u equal to 0 when both v and u are orthogonal in Euclidean space. So here inner product u comma v is 0 if u and v are orthogonal in inner product space. So this is how we can check the orthogonality between two vectors. Okay, so let's do some examples here. So here u is given as 4 comma 2 and v is given as 2 comma minus 2, and the inner product is given as u1 v1 plus 2 u2 v2, and we have to show, the question is show that u and v are orthogonal. So to check orthogonality, what's the equation? U comma v, inner product u comma v equal to 0. When this inner product u and v are 0, we can say u v are orthogonal. Okay, orthogonal. So we need to calculate inner product u comma v. That's the question. Okay, here for u we can write 4 comma 2. For v we can write 2 comma minus 2. Okay, now we need to substitute these values into this expression. Okay, so for that we need to write here for in this inner product here u comma v. For that we have written this is part of u, this is part of v. Okay, then what is u1 and u2? U1 is the first element, u1, this is u2, this is v1, this is v2. Okay, now we need to compute. Okay, u1 v1, that is 4 into 2 plus 2 into u2 v2, u2 is 2, v2 is minus 2. Okay, that's 8 minus 8, which is equal to 0. Oh, beautiful. So here inner product u comma v is 0. So u and v are orthogonal. Okay, we have shown that u and v are orthogonal with respect to this inner product. So that question is solved. Now let's go into the next question. Okay, here what's the question? Find angle between u and v. That's the question. Find angle between u and v. And we have given u is given, v is given, and inner product formula is also given. Okay. So let's write the equation first. So cos theta equal to inner product u comma v divided by length u, length v. So by substituting these values, we will get theta. Okay. So first I am calculating length u. What is the formula of length u? Square root of inner product of u comma u. Okay. Which is square root of inner product of u is 0, 1, minus 2, comma again u 0, 1, minus 2. Okay. This inner product we need to calculate. So here uv, inner product uv is given as this. Okay. So we need to calculate inner product u comma u. So this is u, this is u, and this is u1, u2, u3, u1, u2, u3. Okay. So substituting here, for instead of u1 v1 we get u1 is here 0 into v1, that's next vector. Second vector is first element. Here second vector is this, so first element is 0. Okay. Then plus 2 into u2. What is u2? First vector second element. First vector second element, that's 1, into v2. What is v2? Second vector second element, that is 1, plus 3 into u3 v3. So 3 into minus 2 into minus 2. So what is the answer? Square root. Okay. Square root of 0 plus 2 plus 4 into 3, 12. Okay. So root 14. Root 14 is the length of u. Okay. Now I need to calculate length of v. Okay. Length of v I need to calculate, which is square root of inner product of 3 comma minus 2 comma 1 comma 3 comma minus 2 comma 1. Okay. This we need to calculate. Here I am substituting directly u1 v1, that is 3 into 3, plus 2 into minus 2 into minus 2, plus 3 into 1 into 1. Okay. So the answer will be 9 plus 8 plus 3, square root, square root. So which will be equal to 9 plus 3, 12 plus 8, 20, root 20. Okay. We got length v and length u. So now we need to calculate inner product u comma v. Okay. Inner product u comma v we need to calculate. I am just erasing this so that I can write here. Okay. Inner product u comma v, which can be written as u1 v1 plus 2 u2 v2 plus 3 u3 v3. So I am substituting directly for u1 v1. I can write 0 plus 2 into u2, 1 into v2. v2 here is minus 2, plus 3 into u3. u3 is minus 2 into v3 is 1. Okay. So minus 4 minus 6, which is equal to minus 10. So we got inner product u comma v, the length of u, which was root 14, and length of v. So we have to substitute this into cos theta. Okay. Cos theta can be written as minus 10 by root 14 into root 20. So by calculating cos inverse this value, we get theta as theta equal to 126.7 degree. Okay, this will be the answer. Just do cos inverse of this value, we get that answer. Okay. Now, next question. Here, u is given for 2, v is given 2 minus 2, and inner product u comma v is defined as u1 v1 plus 2 u2 v2. So we need to find the distance between u and v. So what's the formula? Distance between u comma v. Distance between u comma v formula is length of u minus v. Okay. So we need to calculate u minus v first. U minus v. What is u minus v? 4 minus 2. Here 2. Then 2 minus minus 2, which is 4. Okay. So we got u minus v. Now length of u minus v is equal to square root of inner product of 2 comma 4 comma 2 comma 4. Okay. Now substitute this into this equation u1 v1 plus 2 u2 v2. What we get? u1 v1, that is 2 into 2 plus 2 into u2 is 4. v2 is also 4 square root. So root of 4 plus 2 into 4 8. 8 4 32. So root 36, which is equal to 6. Okay, so distance between u and v is 6. Okay, this is how we can calculate the distance between two vectors. So I am finishing these examples. You can comment. I have given one problem. You can comment the answer. Also, you can uh, ask doubts or any future if you need any future sessions, any important material you need, or video update you need, please comment, so I'll be updating next topics. Okay, thank you for listening. Please share it with your friends, and also if you like this kind of lecture, please like and support this channel. Okay, thank you.